We've observed what happens when our two people are going in the opposite direction. Let's now take a look at distance, rate, time problems where our two people are going in the same direction. The key here is to give the person who started earlier a head start. So we add the head start to the time of the person who started earlier, who got the head start. And so we'll have one person catching up with another. If you think at some point in time one person is ahead of the other, then over time, this person will go a certain rate at a certain time. This person will go a certain rate at a certain time. We'll find that the overall distances they travel, including the head start, will be the same. So it'll turn out that one of these will equal the other. So let's take a look at how this actually applies to these problems that we're looking at. For example 1, it says Raquel left the party traveling 5 miles per hour. 4 hours later, Nick left to catch up with her traveling 7 miles per hour. How long will it take him to catch up with her? So we have here that Raquel is going at 5 miles per hour. That would be her rate. Nick's rate is 7. And the thing is, Nick's time is t, but Raquel has been on the road already for 4 hours. So we add 4 to Raquel's time. And then what we're saying here with these head start problems again is that this distance is equal to that distance. So we're saying that these two distances are the same. And we'll use that as the basis for our problem now. Now we have 5 times t plus 4 is equal to 7t. And this should be pretty familiar to you now. 5t plus 20 equals 7t. Here we subtract 5t. 20 equals 2t. We divide by 2. And we have that t equals 10. And so it will take 10 hours for Nick to catch up to Raquel. Let's take a look at example 2 now. Same idea. Now, Trey left on the trip traveling 20 miles per hour. Julian left 2 hours later. So we have Trey and Julian. And it says here Trey is going at a rate of 20, Julian at a rate of 30. But Trey has been on the road 2 hours longer. And then Julian only has t. After how many hours does Julian pass Trey? Again, we set these equal to each other. 20 times t plus 2 equals 30t. And we distribute. 20t plus 40 equals 30t. Subtract 20t. We have that 40 equals 10t. And now we just take care of this by dividing both sides by 10, and we see here that t equals 4 hours. Julian will pass Trey in 4 hours. I find it helps me to remember that you'll always see sort of a reciprocal relationship between rates and times. For instance, Julian's rate is higher, but Trey's time is higher. Raquel's time is higher, but Nick's rate is higher. You'll always see that sort of opposite there.